Okay, I'm going to show you two ways of doing the least squares regression alternative to the high-low method. It's the more accurate of the two, and the formula, sort of longhand, is sort of criminal, and this way we can use Excel and do it very simply. So here's an example very similar to the ones in the book, and set up with an X and Y access information here, patient days, maintenance cost. And I'm actually going to show you two ways of doing it. One, the way I showed you in class with the scatter graph, and putting on the intercept and slope information on there in the RSQ. And then also a second method, which is just to do the formula, do a function to get the same information. So two ways of doing it. The first way, the way I did in class, gives you the calculations and also shows you the actual scatter graph, which is obviously the more visual of the two, and the other just gives you the number. So both ways. Okay, so like I did in class, first thing you're going to do to prepare the scatter graph, as you would with any graph, is select what you want on the graph, which is that information. Click on Insert, Scatter Graph, then the first one up here, and so this should look very similar to the one we did in class. And so here's the trend, or the points on the plots on the scatter graph. And if we were doing this manually, we'd try to draw a line in here that was as straight as possible, getting through as many points as we could, then bring it over here to the intercept line, which would represent our fixed cost. Well, we don't have to do that by our eyes. We can use the computer to do that by right-clicking on the points up here, and then go down here and add a trend line. And to bring it all the way back to the intercept point, we have to go, since there's no zeros over here, we have to come over here and find the lowest one, which is $5,000, and then go backwards on the forecast to bring it back to 0. So we bring that line all the way back, 5,000. And then to display the intercept and slope equation on there, and the R squared value, we click those two buttons, and they show that on there. And this refers back to your book, where total cost equals fixed cost, which is this one, and then variable cost, which is this, x meaning however many units there are. Then the R squared, again, is the quality of fit, how well this line that we've drawn in here matches up with the plot points on the graph. So anything around 90% or above usually is represented to be pretty accurate, and you can see here it does, the lines are pretty, line goes pretty closely to all the points. So that's all the answers. We don't need that. And so this line here, if we were to bring this over, where it meets this axis over here, that represents 3,430.90, representing the fixed cost. Okay, all right. So that's the way we did it in class. And the other way we can do it is just to use a very simple function within Excel, which is the intercept, slope, and RSQ functions. So type in equal sign. Equal sign always has to be before every function or formula. And start typing intercept. Double click on that to accept it. And then all you have to do here is put in the known y's and known x's. So our known y's are here, comma, and then put our known x's in, and then close parentheses, enter. And this is rounded differently, but it agrees with the 3430.9 over here. So the intercept line, or fixed cost, is that number. Slope, we do the same thing, equals slope. Put the known y's in, comma, known x's, close parentheses, enter, 0.759 cents per unit, and same thing over here. There's actually 75.9 cents. I don't know if that's what I said before, but let's say I did. And then the RSQ equals RSQ, which is R squared. Put in our known y's and our known x's, enter, and I should come up with the same thing, again rounded differently, but the whole quality of fit thing, again, the higher that number, the closer to 1 or 100%, would be the quality of the fit, how closely those marks line up, and it also tells us that we can rely on it in our estimates of future activity, which would represent any sort of level of activity on this trend line going out from nothing to infinity up here somewhere. Okay, so that's it. I hope it was exciting for me as it was for you, and there we go.